Good evening, children. Today we are going to start with chemical kinetics and we'll be discussing the PYQs with some concepts. So let us begin. So before beginning, we'll just have a quick introduction that what chemical kinetics deals with, right? So we all know that the term chemical kinetics is associated with the rate of reaction. It is associated with the rate of reaction, right? Now, there are two ways in which the rates of reaction can be determined. And what are those two ways, children? One is the decrease in concentration of reactant or the increase in concentration of product, right? The decrease in concentration of reactant or the increase in concentration of product. In a reaction, we are having two things. One is your reactant and other is the product, right? What happens with time is the concentration of the reactant keeps on decreasing and the concentration of product keeps on increasing. So if we want to find out the rate, so what are we going to do? We are going to express it either in terms of minus dr by dt, okay, or in terms of dp by dt, right? Dr by dt or dp by dt. Yes. So now what is this d? Why did we use the term d here? Okay, we use d here for instantaneous rate. Okay, for instantaneous rate. Suppose you are sitting and you want to know that at 5 second how much progress of the reaction has taken place, how much is the rate of reaction. So that is why we use the term d here, which is your instantaneous rate of reaction. Yes, that is your instantaneous rate of reaction. And why this symbol minus? Why is this symbol minus given? This minus symbol is given to denote that the concentration of reactant is decreasing with time, and there is a plus here. There's nothing means there is a plus sign. So what does it denote? It denotes that the concentration of product is increasing with time, that the concentration of the product is increasing with time. So that is how we are going to denote the rate of a reaction. Okay, so this was the concept here. Then there's one more thing related to the chemical kinetics, that is your rate law. What, children? Rate law. Yes. What is this rate law, children? Suppose we have A plus B give rise to C. There is an equation. Yes? Okay. Now what happens? The rate of reaction is proportional to the concentration of reactants. It depends on some power of the reactants. Okay? It depends on some power of the reactants. So I can say that this rate of reaction is also going to depend on some power of the rate of reactant. Right? Suppose I write here 2a b plus c, right? Okay. Now, in order to remove this proportionality symbol, we introduce the rate constant. And that's why it is written as a to the power x and b to the power y. Yeah, it is written like this. Now, this x and y, what, children? This x and y, these are powers, right? They are powers. And how do you get these powers? You get this power by experimental determination. You get these powers by experimental determination, right? You determine these things experimentally. The values of x and y may or may not be equal to the stoichiometric coefficient. Okay, suppose in one reaction I write k into a to the power 2 and b to the power 1. So here 2 is the coefficient, x equals to 2 is the stoichiometric coefficient of a. Whereas for b, I have written 1, so here it is a stoichiometric coefficient. But if I wrote it this way, Ka and B, so here it is not the stoichiometric coefficient here. So this rate equation, which shows us that the rate of reaction depends on which power of the reactant or the reactant, that is called as your rate law. And In the rate law, we are having the powers x and y. We are having the powers x and y. So if you add x and y together, that is going to be the order of reaction. That is going to be the order of reaction. The order of reaction can be 0, it can be a fraction, it can be a whole number. Yeah. Now your question is, can the order of reaction be negative? Okay, this is your question, and you have to answer me in the comment section. So this is the basics of your rate law order. Okay, so order of reaction can be all this, and so here, whenever there is a equation, whenever there is a reaction, there is some unit for this rate constant. Okay, we knew that this k thing that we have written, that is your rate constant. Okay, and for different orders of reaction, the k value varies, right? The k varies for different rate of reaction. Okay, different reactions, that is your k varies means the unit varies, the unit will vary, right? Okay, so in general, if you want to find out the rate of any reaction, it is written as mole liter inverse 1 minus n second inverse. Yes, so this is the general form of the rate of reaction, and this is very, very important. Why? For example, if you are asked to find out the rate of first order reaction, so what can you do? You can substitute the value of n, where n is the order of reaction. N is the order of reaction. And what are you going to do here? You are going to write mole liter inverse 1 minus 1 second inverse. So it will give you mole liter inverse to the power 0 second inverse. So the answer is going to be, this is going to be 1, and this is only going to be second order, sorry, first order. This is going to be second inverse. So this is your what? This is your unit of rate constant for first order reaction. So whenever you see in a question that the rate constant is given in terms of second order, in terms of second inverse, you are going to identify at once that this is a first order reaction. Yes. Okay. So now I told you that this is the very basis of your rate constant and its unit. So now the question is, this is a previous year question. This was asked in the year 2021 or 20, something like that. Okay, so what is this? For a reaction of order n, the unit of rate constant, what is going to be the unit of rate constant, children? When we know that this is going to be the unit of rate constant, now how can we modify it and write? So if I multiply, this is going to be mole 1 minus n liter minus 1 plus n second inverse, or this can be written as mole 1 minus n L n minus 1 second inverse. So where is this answer, children? This is an option number C. So option C is going to be your correct answer. Yes. Let us move on to the next question. You all can pause this for a moment and try this question. Then we'll discuss the concepts associated with this question. Okay, children, let us discuss what is given in the question. At 30 degrees Celsius, the half-life for the decomposition of AB2 is 200 seconds. We're talking about the half-life here, we'll discuss it. and is independent of the initial concentration of AB2. What is independent, children? The half-life is independent of the initial concentration. The time required for the 80% decomposition of AB2 is how much? This is the question that is being asked to us. Okay. So before starting this, I'll tell you one thing. When you go to the exam, remember log 1 to log 10 ka values, right? This is what you're supposed to remember. This values must be given, I know that, but still for the safety purpose, just remember log 1 is 0, log 10 is 1. So you have to remember log 2, 3, 4, 5, 6, 7, 8, 9, right? That also you don't need to remember. You need to remember log 2, log 3. Then most of the things will be done, like log 4 will be done. Then log 6 can be done. Log 9 can be done. And so all these things can be done. So you have to remember log 5, log 7. Yeah, 2, 3, 5, 7, the prime numbers. Yeah, 2, 3, 5, 7, you have to remember. That will be enough, sufficient for you. Okay, let us discuss this, what is being given here. Now it is telling in the first half of the reaction, what is being talked about. It is talked about the half-life. First we will discuss what half-life is. Suppose you are having a reactant A. You are having a reactant A. You are taking 10 grams of this reactant. How many grams? 10 grams. After certain time, the concentration of A becomes 5 gram. So from 10 to 5, it became half of this. So how much time would be required by the reactant to reduce to half of its initial concentration is called as T half, or that is called as your half-life. Now, T half has a formula 0.693 by K for first order reaction. T half has a formula of 0.693 by K. This is for first order reaction. Okay. Now, this is for your first order reaction. Now, what happens? For your zero order reaction also we are going to discuss, but we'll see for the first order reaction. Now, as you can see, there is nothing here, only K, reaction constant is given, and there is no other concentration like the initial concentration, the final concentration. It is independent of the concentration. So when we see that the half-life is independent of the initial concentration, so basically we are talking about first order reaction here. Okay, so from here one thing is clear, that T half is given to us, and the value of T half is given to us as 200 seconds. Yes, and we know that T half for first order reaction, for which order reaction? For first order reaction, is 0.693 by K. 0.693 by K. So T half is 200. 200 is equal to 0.693 by K. So from here, can I say that 0.693 by 200 is equals to K. So this is one thing that we can conclude from here. You're not going to solve it, just keep it as it is. Now, here we'll talk about the first order reaction and the equation related to it. We all must be knowing the formula of the first order reaction, and that is T equals to 2.303 by K log R naught by R. Log R naught by R. Now, this R naught, children, this R naught is the initial concentration. Initial concentration. This is the concentration after time T. Concentration after time T. For example, if I tell you, you had 50 grams and in time T, 10 grams is reacted. So what is the concentration now here? This will be 50 minus 10. We'll not write just 10. We'll write 50 minus 10. So this 40 is going to be your R, and this 50 is going to be your R naught. Clear? So initial concentration divided by concentration after time T. Okay. So this is the thing. This is the equation which is linked to your first order reaction. Yeah. Okay. Now, talking about this, we want to find out the time. So obviously we'll keep T here. 2.303 by K divided by K. K is 0.693 by 200 log, this is one thing, into log R naught. Now see children, it is 80% decomposed. Means initially can I say that there was 100%? Now 80% decomposed means I can write 100% minus 80%. Yes. So here we'll erase this everything that is above and we'll continue from there. I hope this much is clear to all of you. So we'll erase this part. It's not required to us anymore. So solving this, what are we going to get? We get that T equals 2.303 into 200 divided by 0.693 into log 100% by 80%, 20%, right? So this is going to give you log 5. This is going to give you log 5. So you're not going to use this. This can be used in other ways, but I'm going to use log 5. Log 5, I'll remember the value. It's about 0.695. Yeah. So 2.303 into 200. I'll write it as 0.693. Approx value I'm going to take here. So I'm going to cancel this both. Yes. So if I cancel this both, what are you going to get? You're going to multiply this 2. So this is 3 2s are 6, 0, 6, and this is 2 2s are 4, right? So this is going to be before how many zeros? Before one digit you have to put. So this is going to be 461, nearly 461, or something little bit more than that maybe. So there's only one option where you can see 460s, in the range of 460s, and that is your option number C. So your answer is going to be option number C, which is 467, which is 467. Okay. Moving on to the next question. Okay, I hope you all understood what a first order reaction is. Now, first order reaction is what, children? Suppose you are having R to P. So R is equals to K into R to the power 1. This is your first order reaction. So it depends on the power 1 of the reactant. That is your first order reaction. Yes, we understood that what is the half-life of a first order reaction and what is the formula for calculating the entire rate of a first order reaction. Rate constant and the T. Yes. Okay, let us move on to the next question. Everyone can pause and try it. So let us see, children, what we are talking about in this question. A reaction is given to us here. So we'll just write down the reaction whenever a reaction is given. This is 2H2 plus 2NO give rise to N2 plus 2H2O. This is a reaction that has been given to us. Yes. Now, the rate expression is given to us as R is equal to Kf into concentration of NO whole square into H2. What is this Kf? This is the constant for the forward reaction. Constant for forward reaction. We all know that from equilibrium, K is equal to Kf by Kb. Yes. For reverse reaction means something about the equilibrium is being talked about here. So we know that K is equal to Kf by Kb. Kf is for your forward reaction and Kb is for your backward reaction. And what is K? Equilibrium constant K. We know that that is equal to the concentration of product by concentration of reactant. So can I write here the concentration of product will be N2 H2O to the power 2 divided by NO to the power 2 into H2 to the power 2, right? This is what we are talking about in this part. Now, if I just segregate it little bit, so I can write it Kf by Kb is that much. How much? N2 into H2O whole square NO whole square H2 whole square. We know that at equilibrium, Kf equals to Kb, right? Kf equals to Kb. So can I write it in this term that Kf into NO whole square H2 whole square is equal to Kb into N2 H2O whole square. See, now you are not going to make a mistake here, children, because this is present in your option, but this is not going to be your answer. Why? Because when the rate is written, the rate is not written in this format. What is the rate written, children? The rate is written NO whole square and H2. But here H2 square is there. So I have to write it in that form. This is NO whole square. And I'll write H2 here. This will be equal to N2 H2O whole square divided by H2. This is going to be the format. So this is going to be your answer. Okay. This, children, is going to be your answer, which is in option number B, which is in option number 4, and this is your answer. So do not get confused and write down the third option because you saw it something like this, because you have to bring it in the exact format that is being given in the question. Okay, I hope this was clear to everyone. Let us move on to the next question, but before that, let me check if anyone has any doubt as of now. Okay, let me check. Okay, let us move on to the next question. We'll clear this section. Okay. Next question on your screen, children. There's one more concept associated with it. Okay, try this question, everyone. Take a minute and try this question. Okay, children, let us read out the question. Something is being talked about the decomposition of X. X is being decomposed, right? Okay. The rate constant is given, which is 0.05 micrograms per year. If you look at the rate constant, it's something just like mole liter inverse per second, something just like this. So where, in which equation you are just going to get mole liter inverse? We know that I just told you the formula. This is 1 minus n second inverse. So in terms of n, in place of n, if I put 0 here, if I put n equals to 0, so I'll get mole liter inverse 1 minus 0 second inverse. So this is going to be just 1. So I'll get here mole, liter inverse and second inverse, right? So from here, this is in that format only. So can I say that this is a zero order reaction? Which order reaction? This is a zero order reaction. Yes. Now, as this is a zero order reaction, the time required for the completion of a zero order reaction is what, children? T equals to R naught minus R by K. This is your time required for zero order reaction. Now, talking about the half-life of zero order reaction, if we talk about the half-life of zero order reaction, now initially it will be R naught, but after time T half, this is going to be R naught by 2, yes, divided by K. So can I write this is going to be R naught by 2 by K, or simply R naught by 2K is equal to T half. So R naught by 2K by T half is your half-life for the zero order reaction. So this is the time required for your entire completion of the zero order reaction, and this is for your half-life, which shows that the T half is directly proportional to R naught. Initial concentration is a factor in determining the T half. But talking of the first order reaction, we know that is 0.693 by K, and here it is independent of the concentration because there is no concentration terms in this equation. But here you are having R naught, which is a concentration term, right? Okay, children. Let us discuss what is being talked about here. If we see here, we have R naught minus R by R. So is there something given? Yes, the rate constant is given to us here. That means the value of K is given as 0.05. T is being asked to us. Now initial concentration is given to us, and what is that? That is 5 micrograms. Decomposed into that much means after certain time T, 5 has become 2.5. So R is 2.5. Now can we find T? Yes, easily T can be found out, and this is a very recent question, children. So these kind of easy questions are being asked. You just need to know by looking at the rate constants. So this is 5 minus 2.5 by K. What is the value of K? K is 0.05. So 5 minus 2.5 is 2.5 divided by 0.05. If you multiply into 100, so this is 250 by 5. So this is 50 years. So answer will be 50 years, and 50 is in which option, children? You can see that 50 is in your second option. Yeah, so your answer is going to be 50. Yes, let us move on to the next question. Okay, everyone can pause this again and try. This is a very easy question. Just use some of your brain and you'll be able to answer this very easily. Take 30 seconds for this. Okay, so let us talk about certain things here. What is given? We know that R is in terms of K into AB, right? So initially what happens? This will be K into 0.1 and no, B is changed. This is also 0.1. Then what happens, children? A is how much? A is 0.1, B is 0.3. Now we can see that obviously the rates are changing. R is not equal to R dash. Why? Because that rate is proportional to the concentration of reactants. The rates of reaction are proportional to the concentration of reactants, right? That's why the rate changes. Yeah, what is the first point that we are going to remember here? That the rate changes with concentration. But here it is K and here it is K dash, but K is equal to K dash. What is the thing, children? K is equal to K dash. That means for the same reaction, K will be equal to K dash. Even if you change the concentration, the rate constant is not going to change. Rate constant doesn't change. Because rate constant is independent of concentration. It is independent of concentration. Then it is dependent on what, children? It is dependent on what? It is independent of concentration. If it is independent of concentration, then it depends upon certain other things. And what is that? It depends on temperature. It depends on temperature and addition of catalyst. Addition of catalyst. Okay, so the rate constant will change only if you change the temperature or if you add a catalyst. Okay, so now it is being asked to us about the rate constant. Is there any change in terms of temperature or some catalyst is being added? No. So the rate constant initially was K. So now also the rate constant is going to be K. Yes. So what is going to be the answer? It's going to be K. The rate constant doesn't change. The rate constant doesn't change. Okay. Let us move forward then. I hope you all understood this concept. So on what factors does the rate constant depend and on what factors the rate depends? The rate also depends on surface area of the catalyst. The rate also depends on surface area of reactants. Yeah, okay. Let us move on to the next question, children. Again, a good question. Pause and see. I hope you all would have understood here what is the formula that we are going to use. So if we are talking about the dependence of rate constant, on temperature or activation energy, then there is an equation which gives us all these relation. That is your Arrhenius equation. What? Arrhenius equation. We'll discuss a bit about this Arrhenius equation. Let us write down the Arrhenius equation. So we have K equals to A. This is your Arrhenius equation. K is a rate constant. EA is your activation energy. T is the temperature and R is your gas constant. R is your gas constant. This A is called as a pre-exponential factor because it is before the exponent, right? Pre-exponential factor. Now this is the basics of your Arrhenius equation. We can change it a little bit. Yeah. What are we going to do? We are going to change it a little bit. We'll write it in a different way by taking ln both sides. If we take ln both sides, what are we going to get? We'll get ln k is equal to ln a, and e and ln gets cancelled. So this is going to be minus ea by RT. Yes, it is going to be minus ea by RT. If you look at this plot, children, ln k is there, but 10 to the power 3 RT is not there. So I'll just modify it a little bit. I'll write ln k equals to ln a minus ea by r into 1 by t. So I got 1 by t. I still don't have 10 to the power 3 by t. So what am I going to do here? I'll write ln k is equal to ln a minus of ea by r into 10 to the power 3 into 10 to the power 3 by t. So I have multiplied and divided the equation by 10 to the power 3, both the sides. So this equation basically remains the same, but our purpose is fulfilled, that is ln k, and this is your, this thing we got, right? So this thing, the remaining thing, this is your slope. Yes, this is your slope. Yes or no, children? Why slope? Because this equation is in the form of y is equal to mx plus c. This equation is in the form of y is equal to mx plus c. So if it is in that form, so this is your y, this is your c, this is your m, this is your x, right? Okay. So I can write here minus ea by r into 10 to the power 3 is equal to minus, we know that slope is tan theta. What, children? Slope is always equal to tan theta. Tan theta is equal to perpendicular by base. And here the slope is negative because you can see that the graph is downwards, right? Slope is negative. That's why I've given a negative sign here. Tan theta p by b. So this is going to be 10 by 5. This is going to be 10 by 5. Yes, I hope this much is clear. This part is very, very important. Okay. 5 and 2 minus and minus are getting cancelled. So we have EA equals to 2R into 10 to the power 3. This is in the terms of joule. This is in the terms of joule. The question here is in the terms of kilojoule mole inverse. So here what we got is in the joule mole inverse. What we have to find out is in the terms of kilojoule mole inverse. So I'll divide it by 10 to the power 3. So I'll get kilojoule mole inverse. So if you divide it, you are going to get EA is equal to 2R. What do you get, children? You get that EA is equal to 2R. And it is in which option? It is obviously in the first option. So your answer is going to be option number 1, where EA, the activation energy, is twice the gas constant. Is twice the gas constant, right? So this is what we have here. Yes. Okay. So let us continue and see ahead. Okay. Is there any doubt till this much? Anybody? No doubt? Okay. So let us go forward to the next concept, right? So this was a concept associated with it. So one thing that is continuously being asked from your chemical kinetics is the questions based on Arrhenius equations. Okay. The questions based on Arrhenius equation is a must. Okay. Is a must. So you have to see various questions related to it. So let us move on to the next question, children. You all can pause this again and try this. This is again on the basis of your Arrhenius equation and a little bit different one. Okay, try this. Okay, you can make a change here, children. This is not 106 times. This is 10 to the power 6 times. This is 10 to the power 6. Okay, just make a correction and try it now. So let us read what is given in the question. It's given the rate of a certain biochemical reaction at physiological temperature T occurs 10 to the power 6 times when enzyme than without. Okay, that means it is telling in one case, in first case, you don't have an enzyme, basically a catalytic action. In the second case, you are having enzyme. So as we have discussed that enzyme affects the rate constant. So whenever there is enzyme, your rate constant is going to be affected. Yeah, rate constant is affected. Yes or no, children? So let us discuss how it is affected and what is happening. We'll see here. Okay. So here we are talking about rate constant and activation energy. So which equation are we going to use, children? We are going to use your Arrhenius equation. Which equation? Arrhenius equation. So we know that Arrhenius equation is equal to K equals to A EA minus EA by RT. This is the first thing. Now, what happens when we use enzyme? When we use enzyme, the rate constant changes and it is going to be K dash. Obviously, it is going to be K dash. Okay. Pre-exponential factor is going to be the same. And now one thing you need to know that what happens when you add enzyme. When you add enzyme, the catalyst or the enzyme, it decreases the activation energy. It lowers the activation energy. So now EA is not going to be the same. So EA is also going to change. So this is minus EA dash by RT is same because there is no change in temperature or your R. Okay. So what are the two things that you learned from here? That when you add enzyme, it is affecting the rate constant. It is also affecting your activation energy. Okay, it is also going to affect your activation energy. Basically what it does is it decreases your activation energy. Okay, it lowers the activation energy and reaction occurs fast. Yes, so now we'll write this. We'll take the ratio here. So I'll take the ratio as K dash by K, A by A. So here it is e to the power minus EA by RT. Here it is e to the power minus EA dash by RT. Right? These are the things that is being written here. Now we see that K dash by K is 10 to the power 6 because it is telling us that the rate has been 10 to the power 6 times faster. So if originally it was 1, if this value was 1, now this has become 10 to the power 6 times. Okay, so we'll write here 10 to the power 6 equals to A and A cancel. Now e to the power, okay, just a minute, there's a change here, okay, because this is the new one and this is the original one. So you just make changes here. Yeah, so this was a mistake that we made, just change it because this is E dash, because K dash EA dash, K EA, okay, that is a change that you have to make. So now e to the power minus EA dash minus or plus EA by RT, just the similar case how we do, okay, like something x to the power 2 by x to the power 3. So we write x to the power 2 minus 3. Similarly we are going to write here. Now we want the difference, no children, but this is not in terms of difference. Difference will be what, children? EA dash minus EA. It is telling change in activation energy. So final minus original, so if I want it in that way, what am I going to do? I'll write 10 to the power 6 is equal to e to the power minus of EA dash minus EA divided by RT. Still in the same format. Now still in the format that we wanted here. Yes. So now it is all right. Okay. Now what are we going to do? We'll take ln both sides. What are we going to do? We are going to take ln both sides. So if I take ln both sides, ln 10 to the power 6 will give us e to the, now your e will get cancelled. So this is EA dash minus EA divided by RT. Now if you are converting it into log, if you are going to convert it into log, so if you convert it into log, what are you going to get? You will get this as log 10 to the power 6 is equal to minus of EA dash minus EA by 2.303 RT. Yes, log 10 to the power 6 can be written as 6 log 10. Now this is equal to minus of EA dash minus EA by 2.303 RT. Yes or no, children? This is the thing that we got. Now if we want this, okay, now we have already reached our destination, just a little bit more. Okay, have some patience. This is me solving, so that's why I'm explaining each part, so I'm doing it very slowly. You should be acquainted with so many questions that you should be able to do this in a minute. Okay, so now if I log 10 is 1, children, log 10 is 1, so this will be 6 into 2.303 RT is equal to minus of EA dash minus EA. Yes, but we don't want minus this side, so I'll take minus that side. So this is 6 into 2.303 RT is equal to EA dash minus EA. So we got what we wanted. Yes, we got what we were wanting, right? So this is going to be your answer, and that is in which option, children? It is in option number 4. So option number 4 gives you the correct answer. Option number 4 gives you the correct answer. Let us go ahead and see what comes next. Yes, so this question is done. I hope everyone understood that how these kind of questions are being done. Okay, so let us see, children. Let us go ahead and see the next question. Okay, now this is a very easy one again. You need to pause it and try by yourself. Okay, take a minute for this. Okay. Now again a question on Arrhenius equation. Let us see what is being talked about. Here we are having Arrhenius equation. So we'll write down Arrhenius equation. K equals to A E EA by RT, right? So I'll take ln both sides. So ln K equals to ln A minus EA by RT. Now a plot has been made. They are saying a plot has been made. So let us make a plot just to understand here. You don't have to make it. And there's a negative slope and it is minus y. This is what, children? This is minus y, and the plot is between ln K and 1 by RT. 1 by RT. This is your slope. This is your slope. Yes. Okay. Now if I see, this follows the equation of straight line, right, children? Y is equal to mx plus c. So if I just modify it a little bit and write, x is something that changes, and what is changing? And if I write it in this format, so I'll write it as y equals to ln A minus EA into 1 by RT into 1 by RT, right? Okay. So what's happening here, children? So we have this much. Now ln K is there, ln K is there. So we'll write down ln K here. And 1 by RT is there, 1 by RT. So this is your slope, children. So your M is equal to minus EA. And here your M is equal to minus Y. So can I say that from this both I can conclude or deduce that minus EA equals to minus Y? minus EA equals to minus Y. So what is going to be the activation energy? So the energy required to activate the reactant. So we are talking about the activation energy here. So the value obviously is going to be equal to Y, right? So your EA will be equal to Y. So in which option do you have the answer? You have in option number 4, that is Y unit. Okay, Y unit. Okay, is this clear, children? Is this everything clear, crystal clear till this much? Okay, let us move on to the next question. Okay, try this, everyone. Let me discuss this question here. Okay, now what's happening here? Again, temperature, activation energy, all these things are given. So we know that this is Arrhenius equation, right? Here K equals to A E minus EA by RT. There's one more form to it, and what is that? We just learned that ln K is equal to ln A minus EA by RT. But when we are given two different temperatures, there is another equation to it, which is log K2 by K1, log K2 by K1 is equal to EA by 2.303 R, okay, 1 by T1 minus 1 by T2. This is the equation which you are going to use here, This is a simple equation, and you just have to put the values and get the answer here. So I'll discuss a little bit about it here. Log K2 by K1, the rate of reaction doubles. So log K2 by K1 is 2. So log 2 equals to EA. We don't know what is EA. We have to find out. Divided by 2.303. R is given as 8.314. And here 1 by T1 is 300. 1 by T2 is 310. So everything, if you solve this, you're going to get the answer. I'm not going to discuss the entire process here. So the answer is going to be 53.6. You can solve it and see by yourself. Okay. There's a similar question like this. I'll discuss that. Okay. Now, same question, but a little bit different. So let us discuss what is being talked about here. It is telling that, so we'll write the equation here. Log K2 by K1 is equal to EA by 2.303 R 1 by T1 minus 1 by T2. Yes. Okay. Now, what is being talked here? It is saying that the rate of reaction doubles. So here also it doubles. So this is log 2 is equal to EA by 2.303 R. Nothing else is given. And what is given here? 1 by T1. This is 300 minus 1 by 310. This is given to us. Now, this is not the question here. The question is more. What it is asking? By how much the temperature of B should be increased from 300 Kelvin, so the rate doubles if activation energy is twice. So again, a second case is given to us where it is saying the rate is doubling. So when the rate is doubling, again it is going to be 2 and this is going to be 1. So again this is log 2. If activation energy is twice, this is going to be 2 EA divided by R. Value is not going to change. This here, children, this is going to be 300. We don't know what is T2. So this is 1 by T2. Right. Now we see that the left hand sides are equal. This is equal. So when the left hand sides are equal, obviously the right hand sides are going to be equal. So instead of this, I'll write here EA 2 EA by 2.303 R into 1 by 300 minus 1 by T2. Right. Rest of the things will erase here. Yes, these are not required because we just discussed that they are equal and this is done. Now we'll solve this equation. This is EA getting cancelled, this both getting cancelled. So we have 310 minus 300 divided by 300 into 310 is equal to twice of 1 by 300 T2 into, here what is above, this is T2 minus 300. Okay, so this is what we have to solve. So obviously we can see from here, this 300 and this 300 will get cancelled. Here you are going to 10 and this is, so this is going to be 5. This is going to be 5 and this is going to be 5, 6 at 30 and this is 62. Yes, so all in all we got this is 1 by 62. We got this side as 1 by 62 equals T2 minus 300 by T2. Yes, this is what we got here. We will not solve the entire, I'll not solve it entirely, just giving you little bit hint here. So this is cross multiplication here. So T2 equals to 62 T2 minus 62 into 300. So this will get, so this is 61 T2 equals to 62 into 300, which implies you'll get T2 here 62 into 300 by 61. Yes, so nearly this is 1 point something times. So this will increase by hardly a very less value, that is it will come around 305. It will come around nearly 305. So what is being asked? How much has the temperature? So what is the temperature change? Delta T is being asked to us, which is T2 minus T1. Delta T is being asked, which is T2 minus T1, and T2 will be how much, children? T2 we got, okay, delta T2 minus T1. So new one we got it as 305 and originally you had 300. Okay, so it's 5 units change. Okay, 5 Kelvin. So 5 Kelvin, where it is given, this is 4.92 is the nearest one. So that you can take, and that exactly is going to be your answer. So the answer is 4.92. I solved the entire thing for you. Yes, I solved the entire thing. So this is how you are going to approach the questions. Yes, okay. Moving on to the next question, children. Okay, now the next question on your screen, it is telling that there are different plots here, and the plots are between the rate constant and temperature. Now again Arrhenius question, one more question on Arrhenius question. So in that K EA minus EA by RT, so we see that if you increase T, obviously the K is going to increase exponentially. Yeah, exponentially. So it is increasing exponentially. So which one is going to be the answer, children? Obviously this is not going to this is not, because it is decreasing. So out of this two, but it is telling exponentially. So exponentially means this is going to be your answer. So option number 3 is going to be your answer. Yes, so now here you can see with the equation that when T increases, K is also going to increase, but exponentially. Yes, okay. Moving on to the next question. Okay, what is given in the next question, children? The magnitude of enthalpy change. Okay, delta H being asked. Delta H we know from thermodynamics that it is the enthalpy of products minus enthalpy of reactant. Yes, yes or no, children? So enthalpy of product minus enthalpy of reactant gives you the delta H. Now how are you going to calculate from this reaction? You know that in a reaction coordinate, when something like this is given to you, the one which has the lowest energy, so suppose this is your reaction coordinate and this is your energy, we see that this is the highest point, this is the lowest, and this obviously is your intermediate. Highest point is your what? Transition state. Always transition state. Like you study 10th, you study graduation, in between you study your intermediate, right? So this highest state is nothing but your intermediate. Okay, so this is your transition state, and the lowest is always your product, and the intermediate one is your reactant. So from here you could identify that this part is your product, this part is your reactant. Yes, and we have to find out the delta H, which is product minus reactant. Delta H is your product minus reactant. So we'll erase this and we'll focus on the main thing here. So let's see. Now coming back to product. So this part is your product. So if you see the value of product, this is going to be what, children? Product is from here to here only, from this portion to this portion, and this is given as Z, and Z is 15. So I'll write here 15, okay, minus reactant coordinate. What do you see? The intermediate one, this is this one, A plus B, and A plus B is entire from here to here, the entire thing, and this entire thing is nothing but x Z plus Y, nothing but Z plus Y, and Z plus Y is 45 plus 15. Yes, so this is 15 minus 60. 15 minus 60, so this is minus 45. We'll take the mode of it, so this is going to be 45 kilojoule mole inverse. Okay, this is going to be 45 kilojoule mole inverse, right children? So this is going to be your answer, and if you write, the answer is going to be how much, children? The answer is going to be 45. Okay, I hope this is clear to everyone. Moving on to the last question. I hope this is the last question. Maybe I think this is the last question. We'll check. Okay, now the value of K, again a question from Arrhenius equation. So this is a different one again. So not exactly different, but little bit. A E minus EA by RT. So if we see here, this is given as, if we see, the equation is given as K equals to 6.5 into 10 to the power 12 second inverse e to the power minus 2006 this much K by T, right? Okay, now we'll see that if we compare this A is this one, T is given, that means minus EA by R is equal to this much. Yes, so can I write that minus EA by R is equal to minus 26,000. Now R value we know is given to us 8.314. So minus minus cancel, and we'll write here EA by 8.314 is equals to 26,000. If you multiply this, you're going to get your answer. And what is the answer, children? The answer is going to be 216 point something, as it is asked to us about the nearest integer. So we are going to write the value of the nearest integer, and that is going to be 216. That is going to be 216. Okay. There are no more questions. Okay. I hope this much is clear to all of you, and you all understood how to solve these kind of questions, and you'll practice the similar ones, and these are the concepts that are required. If anything else is needed, just do let me know. Any other concept that you want to know, just do let me know. Okay. Okay then. Okay children, I'll see you in the next class with another new chapter. We'll discuss more concepts, and until then, take care children. Bye bye.